Android devices are everywhere. They have become ubiquitous, permeating every facet of our personal and professional lives. This widespread adoption of Android, while beneficial in many ways, presents unique challenges when these devices are involved in criminal activity. This is where Android forensics comes into play. Android forensics is a specialized field of digital forensics that focuses on the recovery and analysis of data from Android devices. This data can include text messages, call logs, emails, photos, videos, GPS location data, and much more. The goal of Android forensics is to extract and analyze this data in a forensically sound manner, meaning that the integrity of the evidence is preserved throughout the entire process. Android forensics is a complex and constantly evolving field as new devices and operating system updates are released frequently. However, the basic principles of digital forensics still apply. A structured and methodical approach is essential for conducting a successful Android forensic investigation. The importance of Android forensics cannot be overstated. These devices often contain a wealth of information that can be critical to criminal investigations, civil litigation, and even corporate investigations. In criminal cases, Android devices can provide valuable evidence related to crimes such as homicide, assault, robbery, drug trafficking, and child exploitation. In civil litigation, Android devices can contain evidence related to divorce proceedings, child custody battles, and employment disputes. In corporate investigations, Android devices can be examined to investigate allegations of employee misconduct, intellectual property theft, or data breaches. The increasing sophistication of mobile devices has made them a treasure trove of digital evidence. This makes Android forensics an indispensable tool for law enforcement, legal professionals, and security researchers alike. The process of conducting a forensic examination of an Android device follows a structured approach similar to other digital forensic investigations. It generally involves the following steps. This initial phase involves gathering the necessary tools and equipment, such as write blockers, forensic software, and data storage devices. It's also crucial to have a clear understanding of the legal framework and obtain the necessary warrants or consent before proceeding. The device must be seized in a manner that preserves the integrity of the evidence. This often involves isolating the device from any networks to prevent remote wiping or data alteration. Faraday bags and other signal-blocking devices may be used for this purpose. This step involves creating a forensically sound copy of the data stored on the device. This can be done using various techniques including logical extraction, physical extraction, and cloud acquisition, depending on the specific device and the available tools. Android forensics presents a unique set of challenges compared to traditional computer forensics. The diversity of Android devices, the constant operating system updates, and the variety of security mechanisms make it a constantly evolving landscape for investigators. One of the primary challenges is encryption. Many modern Android devices come equipped with full disk encryption, which protects the data at rest. This means that even if a forensic image of the device is acquired, accessing the data without the decryption key or passcode can be extremely difficult. Another challenge is the increasing use of app-specific security measures. Many apps now employ their own encryption or data protection techniques, making it more complex to extract and analyze data stored within these apps. Furthermore, rooting, which is the process of gaining administrative privileges on an Android device, can complicate forensic investigations. While rooting can provide more access to the device, it can also alter system data and potentially compromise the integrity of the evidence. Section 5. Logical extraction methods. Logical extraction involves retrieving data from the device through standard communication protocols and interfaces. This method typically relies on accessing the device's file system using tools that communicate with the Android operating system. One common technique is using the Android Debug Bridge, or ADB, a command line tool that allows communication with an Android device connected to a computer. ADB can be used to pull files, access databases, and even execute commands on the device. Another method is using backup files created by the user or through automated backup solutions. These backups, often stored on the user's computer or in the cloud, can contain a wealth of information including messages, contacts, call logs, and app data. However, logical extraction methods are limited to accessing data that is accessible through the file system or provided by the operating system. Encrypted data, deleted files, and data stored in secure areas of the device may not be retrievable using these techniques alone. Section 6. Physical extraction methods. Physical extraction, in contrast to logical extraction, involves acquiring a bit-by-bit copy of the device's storage chip. This method is more complex and requires specialized tools and expertise. One common technique is chip-off, which involves physically removing the memory chip from the device and connecting it to a specialized reader for data extraction. Another technique is Joint Test Action Group, or JTAG extraction, which utilizes a hardware interface designed for testing and debugging embedded systems. JTAG allows direct access to the device's memory, bypassing the operating system and any security mechanisms in place. Physical extraction methods are more likely to recover deleted data and access encrypted information, as they bypass the limitations of the operating system and provide direct access to the storage medium. However, these methods are more invasive and carry a higher risk of damaging the device. They also require a higher level of technical expertise and specialized equipment. Section 7. SIM card forensics. The Subscriber Identity Module, or SIM card, is a small, removable card that stores essential information for identifying and authenticating a subscriber on a mobile network. SIM cards can contain a wealth of information relevant to an investigation, including the subscriber's phone number, contacts, text messages, and call logs. In some cases, SIM cards may also store data related to mobile payments or other applications. Forensic examination of a SIM card typically involves using a SIM card reader to access and extract data. This data can then be analyzed using specialized software to uncover communication patterns, contacts of interest, and other relevant information. Extracting data from a SIM card can be crucial in cases where the device itself is encrypted or damaged. Section 8. Newer versions and security enhancements. The landscape of Android forensics is constantly evolving as new versions of the Android operating system are released and manufacturers implement additional security enhancements. These updates often introduce new challenges for forensic investigators. For example, newer versions of Android have implemented stricter security measures such as verified boot and file-based encryption, which make it more difficult to gain unauthorized access to the device or extract data. Additionally, features like Google's Safety Net aim to detect rooted devices or devices with modified operating systems, which can hinder certain forensic techniques. The increasing use of biometrics such as fingerprint scanning and facial recognition for device unlocking also presents challenges. While these features enhance security for the user, they can make it more difficult for investigators to access the device if the user is unavailable or uncooperative. Section 9. Conclusion. Android forensics plays a vital role in today's digital investigations. As Android devices become increasingly prevalent, so too does the importance of being able to extract and analyze data from these devices in a forensically sound manner. While advancements in technology have led to increased security measures and challenges for investigators, they have also led to the development of new tools and techniques to overcome these obstacles. The field of Android forensics requires a deep understanding of both the Android operating system and the principles of digital forensics. As technology continues to evolve, it is essential for forensic practitioners to stay abreast of the latest advancements and challenges in this field to ensure that they have the knowledge and skills necessary to conduct thorough and effective investigations.